You type a question into ChatGPT 5, something simple, like, why is the sky blue? You press enter, and then, in just a few seconds, you get a detailed, human-like answer that explains light scattering and wavelengths in a way that actually makes sense. But what just happened in those few seconds? Where did your words go? What actually processed your question? And how did a machine generate an answer that sounds like it came from a person who genuinely understands what you're asking? In this video, you're going to follow the complete journey of your prompt, from the moment you hit enter to the second that answer appears on your screen. You'll discover what happens behind the interface you see every day. You'll learn why it takes a few seconds and not instant. And you'll understand why sometimes these AI chatbots give you exactly what you need, and other times they confidently tell you something completely wrong. But before we dive in, let me explain something. I started this channel a few months ago with zero experience. Make sure you like this video and subscribe if you want to join my journey to 1,000 subscribers. Now, let's follow your question on its journey. The moment you press enter, your question doesn't go directly to some super intelligent AI brain. It first hits OpenAI's servers. And the very first thing that happens is your question goes through a safety filter. This filter checks if you're asking for something harmful, illegal, or dangerous. Think of it like a security checkpoint at an airport. Most questions pass through instantly, but if you ask ChatGPT how to make explosives or write malware, this filter catches it before your prompt ever reaches the actual AI model. The system politely refuses and moves on. Let's say your question about the sky passes the safety check. Now something interesting happens. Your words get transformed into numbers. AI models don't understand words the way humans do. They understand math. So every word you type gets converted into what's called a token. A token is basically a chunk of text that gets assigned a unique identification number. Sometimes a token is a whole word, like sky. Sometimes it's part of a word, like ing, in running. And sometimes it's just punctuation. Your question, why is the sky blue, might get broken into tokens like this. Why is the sky blue? And question mark. Each of these gets assigned a unique identification number from a massive vocabulary of about 200,000 possible tokens. But it's more complex than just swapping words for numbers. The system also needs to understand the relationships between these words. This is where something called embeddings comes in. Imagine every word existing in a massive multidimensional space. Words that appear together frequently in human writing end up closer to each other in this space. So sky would be near clouds, weather, and blue. Meanwhile, sky would be far away from words like submarine or keyboard. ChatGPT's current model, GPT-5, represents each token in up to around 3,000 dimensions. You see in this example only 3 dimensions, because humans can't visualize thousands of dimensions. But mathematically, it's just a huge list of numbers that captures the essence of what each token means based on how it's used in billions of human-written sentences. So now, your question isn't just a list of word numbers. It's a massive mathematical representation that captures meaning, context, and relationships between the words you typed. This representation then enters the actual neural network, the AI brain. And this is where things get really interesting. The neural network is structured in layers. GPT-4 is estimated to have 96 layers. The exact count for GPT-5 hasn't been revealed, but it uses a dynamic architecture with an adaptive number of layers rather than a fixed count. Your question enters the first layer and passes through various layers sequentially, getting transformed at every step, often activating only the necessary experts within those layers for efficiency. At each layer, something called attention mechanisms come into play. This is probably the most important innovation that makes modern AI chatbots work so well. Attention lets the model focus on the most relevant parts of your question. When you ask, why is the sky blue? The attention mechanism realizes that sky and blue are the key words. It pays less attention to why and is and the, because those words, while necessary for grammar, don't carry as much meaning. If you asked a more complex question like, when I look at the sky during sunset, why does it turn orange instead of blue? The attention mechanism would focus on different words, sunset, orange, blue, and understand that you're comparing two different states of the sky. The attention process happens multiple times simultaneously within each layer. GPT-4 has an estimated 96 attention heads per layer, not processing sequentially, layer by layer. With each pass through the entire network, the model builds a deeper understanding of what you are actually asking. But here's the critical thing to understand. The model isn't thinking about the sky. It isn't remembering what blue looks like. It has never seen a sunset. What it's actually doing is statistical pattern matching on a scale that's hard to comprehend. During training, GPT-5 was fed hundreds of billions of words from the internet, digitized books, Wikipedia, scientific papers, Reddit threads, news articles, everything. It learned patterns. It learned that when people write about the sky being blue, they often mention words like light, atmosphere, wavelength, and scattering. So when your question about the blue sky passes through all the layers of attention and processing, the model isn't understanding physics in a human conscious way. It's calculating probabilities. Based on everything it learned during training, it determines what words are most likely to follow the pattern. Why is the sky blue? Leveraging complex internal patterns that enable sophisticated reasoning and problem-solving capabilities. And that calculation happens for every single word in the response. After your question has been fully processed through all the layers of attention and processing, the model generates an answer one token at a time, not one word at a time. One token, which might be a whole word, part of a word, or punctuation. It looks at your question and everything it's learned and calculates which token has the highest probability of being a good start to the answer. Let's say it picks the, then it looks at your question plus the, and calculates what token should come next, maybe sky. Then it looks at your question plus the sky, and picks the next token, appears, then blue, then because. This continues, token by token, until the model decides the response is complete. This is why you see ChatGPT's answers appear gradually, word by word, instead of all at once. Each token requires a complete pass through the neural network's calculation process. And here's something important. The model adds a small amount of randomness to these probability calculations. If it always picked the absolute highest probability word, its answers would be repetitive and boring. The randomness makes responses more natural and varied. But this randomness is also why sometimes ChatGPT gives slightly different answers to the same question. And it's part of why the model can confidently give you wrong information. The model doesn't know what's true. It only knows what patterns appeared most frequently in its training data. So if many low-quality sources on the internet confidently stated something false, and that false information appeared frequently enough, the model might reproduce it. Because remember, it's not thinking or reasoning about truth. It's pattern matching and probability calculation. Once the complete answer is generated, word by word, it goes through one more safety check before you see it. OpenAI doesn't want ChatGPT generating harmful content, even in response to innocent questions. So there's a final filter that screens the output. If everything passes, the answer finally appears on your screen. The entire process, from you pressing enter to seeing the first word of the response, usually takes just a few seconds. But in those few seconds, your question was converted into numbers, processed through 96 layers of a neural network containing billions of calculations, and an answer was generated one word at a time through statistical probability. This same basic process happens in ChatGPT, Claude, Gemini, DeepSeek, and every other modern AI chatbot. The specific details vary. Different models have different numbers of layers, different training data, different attention mechanisms. But the fundamental journey is the same. Text becomes numbers. Numbers get processed through layers of attention and calculation. Probabilities generate new text, one token at a time. And this is why these systems are so powerful and so limited at the same time. They're powerful because they've learned from essentially all human writing on the internet. They can generate responses on almost any topic because somewhere in their training data, humans wrote about that topic. They can write poetry, explain quantum physics, debug code, and have conversations that feel remarkably human, but they're limited because they don't actually understand anything. When ChatGPT explains why the sky is blue, it's not visualizing light hitting molecules in the atmosphere. It's not thinking about what blue looks like. It's calculating that based on billions of examples of human writing, these specific words, in this specific order, have a high probability of being a correct and useful response to your question. This is why ChatGPT can pass medical licensing exams, but shouldn't be trusted with actual medical advice. It's pattern matching on a supernatural level, but it's still just pattern matching. It doesn't know when it's wrong, because it doesn't know what being right or wrong means. It only knows probabilities. Understanding this matters because AI chatbots are rapidly becoming infrastructure. Students use them for homework. Programmers use them to write code. Businesses use them for customer service. Researchers use them to analyze data. And all of this happens through the same process. Your words become numbers. Those numbers get processed through probability calculations. New numbers become words that appear on your screen. It's simultaneously more mechanical and more impressive than most people realize. More mechanical because there's no consciousness, no understanding, no actual thinking happening, but more impressive because this mathematical process of pattern matching produces results that consistently fool humans into believing there's real intelligence on the other side of the screen. So the next time you ask ChatGPT, Gemini, Claude, or any other AI chatbot a question, you'll know what's really happening. Your words are being converted into approximately 3,000-dimensional mathematical representations, processed through many layers of attention mechanisms, and transformed into probability distributions that generate text one token at a time. And somehow, despite being nothing but math and statistics, it works well enough that within just 3 years, these chatbots went from science fiction to something 800 million people use every single week. If you found this explanation valuable, please hit that like button and leave a comment. What surprised you most about how these systems actually work? And don't forget to subscribe for more deep dives into the technology changing our world. Thanks for watching.